Welcome to the second video on chapter 3. We're going to begin with 3.4, which is angle-side angle and angle-angle-side congruency. So in this chapter there's two new ways that we can figure out that two triangles are congruent. So the first way is going to be angle-side angle congruency. So that is what it sounds like. And so basically we have these two triangles here and we have angle. Then we have this side is equal to this side. And then we have these two angles are equal. Then we have that these two triangles are congruent. So basically, the new way to do it is angle, side, angle. So if you find two triangles and you can prove that they have an angle that matches up, then a side that connects the two angles, then another angle that's the same, then you can prove that these two triangles are congruent. And now in 3.4 there's also a second way, and that's going to be angle, angle, side congruency. So that is what it sounds like, and so it's angle, another angle, and then we're going to have a side. Now the important thing is, for this one, that basically the side has to be the same. So it has to be this angle is the same as this angle right here is the same as this angle, and these sides have to be these sides. It can't be that this side right here is the same as this side right here. That's not the same because it doesn't match up. So it has to be this side with this side because the order matters. You can have it where you could have that basically this side, if you forget about this and this for a moment, this side is this side, and then you could have angle, angle, but you can't have that is angle, angle, side, and then you can't have angle, angle, side and expect the two to equal. It has to be where if you lay them on top of each other, the sides are going to match up and the angles are going to match up, and that wouldn't work the other way. So that's what's important to remember with this, in like the same order if you would think of it. So it has to be this, and then this, and then that side, or you could have it this, this, and then side like this. But it has to match up with the two triangles, and that's what's important to remember with angle, angle, side. Now I'm going to go over 3.5 really quickly. It's basically on side, side, side angle congruency, and what they're trying to say is it's not a viable way for you to find congruent triangles with side, side angle. So if you think about it, side, side angle. So let's try this right here. So let's say I have a side right here and a side right here. This is 6, this is 6. And I have, let's say, another side right here and another side right here. This is 9 and this is 9. So if I have this angle right here, if I have this angle, and it's the same as this angle right here, that doesn't mean that this angle right here and this angle right here have to be the same. So I could have something that looks completely different. So if I draw it out, I could have two completely different triangles that have the same sides right here and here, and the same angle here and here, and they won't be congruent triangles. So if I draw this out and I have 6, so let's draw this. So if I have 6, 9, the same angle right here, let's say this, so 6, 9, ignore this up here. So if I have 6 and 9 and 25 degrees right here, I can also have 6 and 9. This is also 25 degrees, let's say. These two triangles are not congruent. This side doesn't have to be the same length as this side, so that doesn't work at all. And so these two triangles are congruent, and so side angle side is not a good way to get congruent triangles. So I'm going to move on now to 3.6, which is on isosceles and equilateral triangles. So I'm going to begin with equilateral triangles. It's really simple. So if you look at a triangle, an equilateral triangle is where all the sides are equal. So it looks like this. Then if all the sides are equal, then we're also going to have all equal angles. So this angle is equal to this angle is equal to this angle. Now, inside of a triangle, the angles will equal 180. And because there's 3 angles and they're all the same, 180 is divided by 3. And so we get all the angles are 60 degrees. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. So this is what an equilateral triangle is. So if you're solving for parts of a triangle, just remember that if any three angles in a triangle are equal, then so are the three sides. And the same way, if any three sides in a triangle are equal, then the three angles are equal. And that's what an equilateral triangle is. And now I'm going to move on to an isosceles triangle. And so in an isosceles triangle, there's a little bit of vocab. It's not that hard. So these two, right here and here, these two sides are called the legs. And this side down here is called the base. And so in an isosceles triangle, the legs are equal to each other. And this up here is called the vertex angle. And these down here are called the base angles. And in an isosceles triangle, the legs are equal and the base angles are equal. So if you have that the legs are equal to each other, then the base angles must also be equal to each other. And if you ever have a triangle where you find the base angles are equal to each other, then the legs must also be equal to each other because it's an isosceles triangle. That's very simple and straightforward, and this is what an isosceles triangle is. It's very easy to remember. Now I'm going to do one of the problems from 3.6, problem 3.17. And so in this problem it asks us to find angle A. So we're going to do this by using isosceles triangles. And so what we're going to do is, because this is an isosceles triangle right here, we can tell that this angle right here is 23 degrees as well, because this is 23 degrees and it's an isosceles triangle. And so these are both base angles. And because this is an exterior angle, we can tell that this angle right here is equal to this plus this, so this angle is equal to 46 degrees. Now, because this triangle is also an isosceles triangle, because the legs are equal, this angle right here is equal to this angle right here. So angle A is equal to 46 degrees. Quite simple. And now I'm going to move on to 3.7. So 3.7 is the last section in chapter 3 before the summary, and it's fairly simple. So first they give you a couple of rules that you can use, and they're operations that you can perform with your compass and a straight edge. And so there's a few of them, and we're going to begin with number 1. It's fairly simple, and that's given a point, you can draw a line through it. And so that's just, if I have a point right there, I can draw a line through it. And then number 2, if you're given 2 points, you can draw a line through it that passes through both of them. So if I'm given this point and this point, I can draw a line through it, passes through both of them. So these are really simple. And number 3, given a point, you can draw any circle centered at that point. So if I'm given a point here, I can draw any circle centered at that point. And you can do that with your compass and straight edge, but I'm on a computer here, so I just did that. And now number 4 is quite simple too. Given a point and a segment, you can draw a circle with its center at the point and with its radius equal to the length of the segment. So what they're saying is, if you're given basically a point and a segment, you can, let's say you have this right here in a point and a segment. Hang on one second. And now number 4 is fairly simple. Given a point and a segment, you can draw a circle with its center at that point and with the radius equal to the length of the segment. So what that's saying is, if you're given a point like here and a segment that goes all the way out, that segment is going to be the radius of that circle. So just imagine that's a perfectly drawn circle. And so basically, if you take a segment and then wrap around the edge of that segment, it's going to make the edge of the circle. So if I did that here with this, see, this is the segment, and it just takes the outside point, and that's going to be the edge of the circle. And so number 5 is, given 2 points, you can draw a circle through one point such that the other point is the center of the circle. And so using this circle again, so the 2 points could be here and here, and that's just, if I draw a circle, then I can have one point being the center, and this point is just the distance between the 2 points is the radius, and so you just draw the circle around and you have a circle with a center point, and then the distance between the two is the radius. Then the final part of 3.7 is on perpendicular bisectors, and all a perpendicular bisector is, it's where a line bisects another line, and it happens to be perpendicular to it. So that's what a perpendicular bisector is. So this line is bisecting this line, so it splits it in half, and it's perpendicular to it, and that's what a perpendicular bisector is. And that's the end of chapter 3. I'll see you in the next video.